Anyone's getting audio?
Hello and welcome to the Logic and Reason Show. I am your co-host, Logical Troglodyte. With me is my good friend, Steaming Cup of Reason. Jeff, why don't you introduce yourself?
Well, hello everybody. Steaming Cup of Reason here. How you doing, Logical? Good to see you again.
Yeah, it's a great day.
Yeah, it is. We're looking forward to a really great show tonight. We've got, first of all, Blue Marble Science. He's going to be joining us as we discuss tonight's topic. Blue, why don't you introduce yourself?
Well, hello, guys. Blue Marble Science is my channel. I'm just a retired guy that, for some reason or the other, likes to play with YouTube and flat earthers. So that's about it, fellas.
Well, there's a little more to Blue Marble Science's channel than that, but after the stream, if you don't know who he is yet, then you must have been living in a cave. I encourage everybody to go over to his channel and check it out. Link is in the description box. Also joining us tonight is Mike Bertelson, returning from last week for this week's show. Hello, Mike. How you doing?
Doing good. I'm Mike the engineer, and I'm here to talk about globe-denying conspiracy theorists.
And as always, the man of few words, but he knows how to really use them. Our chief mod tonight will be Amy Hogan. Amy, say hi to everybody.
Hello, everyone. How are you all tonight? I'm excited for a great conversation.
You got anything going on in the world of YouTube you want the audience to know about? And show yourself a little bit before we get started, Amy?
Not right now. No, we're still working on the autism show. We're hoping to get that up and running very soon. And that's pretty much it. Just chasing around the kiddo. So that's pretty much it.
Great. And working in the background with us, we have our executive producer, Dick Dawson. Dick, say hi to everybody. Tell them what you are, who you are.
Well, hello, everybody. I'm Dick Dawson, playing the executive producer role here for the fantastic Logic and Reason show. You got to love this, guys. Come on. We got Big Blue himself, Blue Marble Science, and Mike Bertelson, one of the smartest men you'll ever talk to, with two great hosts and an amazing co-host. This is fantastic. Thanks for having me on again, guys.
Yeah, thanks for coming by, Dick. And working the whistles, bells, and dials, we have our broadcast and engineer working hard in the background to bring us a great show, Taddy Bogle. Say hi, Taddy.
All right, troops. All right. How's it going? I'm just really looking forward to this one once again. Another belter of an episode, and what a conversation we're going to have tonight, man. I'm really looking forward to just listening in and learning something.
And a little housekeeping before we get started. Amy Hogan is our chief mod, and people with the wrenches in blue in the live chat, you are temporary mods during this stream. If we get any conspiracy theorists in the stream, go ahead and let them be here. That's fine, as long as they're not being complete jerks. The only real no-nos are racist remarks, things like homophobic remarks, that sort of thing. They can ask questions, they can make comments, and we might even address them during the show if they choose to ask us questions, provided they are on topic. Now, tonight's topic isn't necessarily flat Earth. It is the conspiracy claim that gravity is not real and all that is required is density and buoyancy. So, without further ado, the battle for density versus gravity is on. Gentlemen, what do you got to say about this?
Well, it's not really much of a battle.
Yeah, I'm trying to figure out who's going to be on the other side of this one, because they're going to lose bad.
Well, I was thinking that conspiracy theorists tend to conflate common use vocabulary with vocabulary. And I have already had a beer and I can't hardly talk already. So they tend to conflate scientific terminology with common use vocabulary. So just to make sure that we and our audience at home is on the same page, why don't we go over a few terms and definitions that we will be using tonight, things like specific gravity, relative density, and that sort of thing. Mike, you want to get it started on that?
Well, relative density, that's a term that I'm not even sure why they're using it, other than to make up some magical force, but it's just nothing but the difference between the density of two things. Why it's relative, and nobody really cares, because it really doesn't have any effect on our reality. It's not even really a term that was used in science or physics or engineering. Like if in engineering, if we're talking about something associated with this, it's usually a specific gravity or specific volume, depending upon how we're approaching things. So as far as relative density goes, yeah, it kind of really is something, but it has no actual meaning, no actual use.
Okay. And Blue, you got anything, any of the conflation of terms and definitions that you might want to address as we get started?
Well, Mike summed that up very well, I think. In the field of engineering or physics or science, we typically use the term specific gravity, and that normally relates the density of a material to the density of water. That's an easy one to figure out, just simply because water is a readily available reference substance. Everybody's familiar with it. And it works quite well for pretty much everything. I mean, even the heaviest things. I think the specific gravity of lead is something like 13.8. So it's, you don't get crazy, wacky numbers. When you simply say relative density, relative to what? That's and that's the point Mike made. But they'll throw another term into and mix it in with this, which they refer to as disequilibrium. Which is amusing, because it's a term typically used in economics or finance. I think we understand what they're trying to say, but it's not a common term we find in science or physics or engineering.
They're very imprecise terms.
Yeah, it could take on lots of meanings, I think.
So it's one of those terms that, say, a less educated person than yourself would use when they try to sound smart, but kind of really don't know what the hell they're talking about.
That's one way to put it. Yep.
Okay. Yeah, I just try to keep things simple. And as far as gravity versus density, I think there is a confusion as to, well, there's a lot of confusion when it comes to gravity, even if you're not a conspiracy theorist, because, yeah, I know that gravity is the thing that makes me fall down and go boom, and I get a bimp on my forehead, and then I have to go to the emergency room in case I have a concussion. But when we start talking about Newtonian gravity versus Einsteinian gravity and then quantum gravity, my head tries to explode.
Well,
I think that's pretty common for most laymen. I mean, it's a pretty abstract concept, and because they don't really understand it, they misrepresent it in their narrative.
Well, it really doesn't have to be all that abstract. For as far as us in what we would consider a local frame of reference on the Earth, it really is as simple as you fall down. It is an action. It's a reaction. It's quantifiable. It's something everybody can see, and if they really wanted to, anybody can actually measure using a ball on a square grid. And it doesn't have to be. Yeah, I mean, you could use Einstein's field equations to calculate how a ball is going to go up and down when you throw it. It would be way overly complicated, not even more accurate. And Einstein's general relativity, he actually shows how in the local frame of references, he's talking about things like Earth. Einstein's equations match Newtonian gravity equations. It works out to be the same things. So you don't have to go wading through the general relativity and special relativity papers to figure out how to calculate how things fall, how to measure how things fall. It's all as simple as just looking in general observation.
Yeah.
Well, Newton summed it up pretty handily. All those years ago, when was it? Early 1600s or something like that. With his equation, which I think they get a bit confused about. They have a lot of people have a hard time understanding gravity not being a force. But in reality, Newton wasn't really saying it was. If you think about it, gravity is expressed as an acceleration, not a force. Here on Earth, it's 9.8 meters per second. That's the acceleration of gravity. That's how you can figure out how quickly something is going to fall to the ground from any altitude, and how fast it will be going when it hits the ground. It's a very simple, very elegant equation that Sir Isaac came up with for us. What he had a hard time with was explaining what caused it. Einstein came along and fixed that with his theories, but as Mike said, there's no point in going through the Einstein field equations. They're very complicated and they're very hard to understand. Even experienced people have a lot of trouble with those things, and we don't need them for most things. Once in a while it comes into play. Newton works fine unless you have extremely large objects, extremely massive objects, or you have something that's moving very, very quickly.
Relativistic speed too.
Yep.
It's kind of like in traditional mechanics, gravity is just considered a force. But when you move beyond that, you start getting into the concept of dividing those forces into fundamental and non-fundamental forces. That kind of is where I get a little confused.
In most of the equations you see for things falling, projectile motion, and even the buoyancy equation, you really only see the one acceleration term. Everything else just falls into place after that. So, we don't, like Big Blue said, it usually isn't expressed directly as a force. It's treated as an acceleration. And there's an associated force with it, but weight, for instance.
Yeah, and Blue said something that caught my attention. He said, here on Earth, it's 9.8 meters a second squared. So that means on another body, say Mars or Jupiter or the moon, that acceleration is different because of the masses of those objects. Do I have that right?
Yeah, absolutely.
Yeah. So say the moon landing deniers, okay, that's one of those conspiracy theories where they try to say that the moon landing didn't really happen and the people bouncing around the moon, that's just slowed down camera footage, but that doesn't quite work that way when you really look at that footage and use then the moon's gravity, which I think, if I remember right, is what, 1/6 of Earth, and plug those numbers into that equation and see how they should be bouncing, or how the rock that they're, the golf ball that they're hitting should be traveling, right?
Yeah, that's right.
And the mass of that golf ball is the same on the Earth as it is on the moon. It's just that the acceleration that applied to that object due to gravity is different. So the weight is what's really different between the two. The mass is a constant. It's a material property.
Yeah, you know, I think that confuses people too a little bit, Mike.
Yeah, it does.
Why don't you give them the difference in weight and mass?
Yeah, well, weight is when you're using English, we like to use SI units for this because you get into English units and it gets really complicated difference. But basically, mass is the amount of mass in an object, and we measure that in kilograms.
Yeah, the amount of
But
stuff.
the weight, right? But the weight of that object is that mass times that acceleration. That's the force. In SI units, that would be newtons. So the actual weight of whatever it is you're measuring depends on the acceleration due to gravity and whatever frame of reference you're in, whether it's on the Earth, whether it's on the moon or the surface of Jupiter. If we could ever walk on the surface of Jupiter, not like it actually has a surface, but so the force is actually the mass times the acceleration. So the mass is constant no matter where it is you are, wherever you go. One kilogram mass is 1 kilogram is 1 kilogram. I know that we like weigh things, it says a kilogram, but that's not really the weight of that object. It's and that's what confuses a lot of people too. And in an English unit, you got the mass is a slug, and then you have pounds force or pounds mass, depending upon how you want to look at it. And you got 30 instead of 9.8 meters per second squared. It's like, was it 32.174 or something?
Yeah,
feet per second squared.
Yep.
So it does. It gets a little complicated when you're trying to figure it. Even first year physics and engineering students, especially when they start bouncing back and forth between units, whether it's SI units or standard imperial units, it can get kind of confusing even for those guys who do it. So you kind of have to be careful. That's why vague terms like relative density that are imprecise really doesn't tell you the story of what's going on. And that's why you have to use the right terms if you're going to discuss these things.
Yeah, absolutely. And Amy's kind of poking me in the ribs. Apparently, she's got some really good comments in the live chat that she wants to bring to our attention.
Cool. Yes, please. Thank you. Okay, Demonic Davros says when a black hole is disrupted, the Hawking radiation shows gravitational waves. And then he also said if something accelerated, it required a force. And the conspiracy said, can you have one of your guys explain per second? That may help as far as flat earthers are concerned, because they seem to get that confused.
As far as gravity waves go, you're really getting deep into it there. And we've actually recently measured those using the LIGO detectors, the laser interferometer gravity wave LIGO observatory. That's what the O is. And so that is something that is predicted and has actually recently been measured. If anybody's ever interested, you can download a piece of software called BOINC, BOINC. It's the Berkeley Open Interface for Network Computing. And you can be part of the Einstein project. And they'll actually send your machine data from the LIGO observatories to crunch the numbers. It's a kind of what they call a distributed computer. If you basically have one big supercomputer with tens of thousands of processors, you can crunch the numbers a lot better. So if anybody's ever interested in getting involved in that, it's a pretty cool system. And they have other projects too. As far as the per second, we kind of normally it is. I use per second squared because it's easier for someone to visualize that. But it's actually an acceleration rate. So in that first second, you're moving at 9.8 meters per second. That's your velocity in whatever direction you're going. And then you get this next second, it starts to square. So you're increasing by that amount. And if you look at all the equations where something's fallen, your basic little falling equation, the other term in there is time. So you're left with, meters per second as your speed in the end. So you can calculate that, and then you can also move on to calculate how far you've traveled and all that other stuff. But the per second is just, it's per second squared. It's an acceleration.
Yeah, maybe on a even more fundamental level, just for anyone out there all that curious about it. You use velocity all the time in your day-to-day life. That's what the speedometer in your car is showing you. Distance per unit time, miles per hour, meters per second, same thing. That is a velocity, but that is a constant velocity. When we talk about acceleration, it's the rate of increase in that velocity. That's what the seconds per second, the second squared is about.
Yeah, the additional the time rate change. Yeah,
it's not a constant speed; it is an increasing speed. Each second it increases by another 9.8.
It could be a decreasing too. But...
It can be decreasing too. Exactly, it can be a deceleration.
So if you got a really nerd brain and you jump out of an airplane at 30,000 feet without a parachute, you could have a lot of fun figuring out how fast you're going to be traveling before you hit the ground, right?
Before the splat, yeah.
Yeah.
You will reach a point of what's known as terminal velocity.
Yes. Yeah, and that takes into account some fluid dynamics. Boiled down to pretty much a simple equation, but it has to do with cross section too. So,
and we kind of touched a little bit on how gravity is affecting density to create the weight. And as I recall, Newton really only chose the word gravity because that was a common use word in his era that simply meant weight. Am I correct?
Yeah, it goes back to the Roman times, I think.
Yeah, something like that.
Yeah.
But how does gravity affect then buoyancy? Because that's also part of the conspiracy thinking arguments.
Yeah, it is.
Oh yeah.
They love to use that one.
Yeah, if they understood it, it would be good. You can think of it as the fluid, the water that your boat is floating in. It also is subject to that same gravity, so it's trying to pull down, and it's also trying to find, that local level. I hate to start talking that way because then some conspiracy theorists are going to latch on to that. But you can think of, if you take the boat out and the water just stays the shape of the boat, so you have this little boat-shaped hole in the water. Of course, some people call a hole in the water you throw money into. When that water wants to flatten back out, it wants to fill in that hole. So is the amount of water you're displacing is the same as whatever it is the boat weighs. It's gonna reach an equilibrium between the two, and it's just gonna settle in, and you're gonna float. And that's really all buoyancy is, but it relies upon gravity. If the gravity didn't exist, then that boat would never float. I mean, it would sit, if it would float, if you put it down, it just sits there. Push on it, and it'll just go right into the blob of water. The directionality of this all relies solely on gravity.
So without the gravity, the boat, just the keel would be sitting on the water, or would it displace any water? It wouldn't really displace the water then, would it?
No, only if you apply a force to the boat to push it into the water would it displace any water. And then there's nothing really to stop it from moving through that water too. Once you apply that force, it'll just keep on going. The only thing that makes it actually float is that vector, that force applied by gravity.
Yeah, the water, the boat, and everything else would have no direction, no preferred direction. Just exactly like the stuff you've seen on Well, the ISS or the vomit comet in microgravity, you see how water behaves. It just wants to turn into a spherical blob of stuff, and nothing wants to be attracted to that or sink down in that for any reason other than you pushing it in there. Mm-hmm. Something has to provide a force. Gravity is the thing that does that.
Yep. And that's one of the things too that certain conspiracy theorists don't realize is that the demonstrations they do, like a neutrally buoyant egg, actually debunks the whole concept of relative density as a force, and they have no idea that they're actually doing it that way. That demonstration Anthony Riley did with the egg in the saline solution. He even talked about how the saline solution was at a gradient, and watch what happens when I stir it, and that egg moves up through the water column just like it should. It's actually a very, very cool demonstration of neutral buoyancy. I actually like that demonstration. And he adds salt in the water, then the egg then again rises farther through that water column. But here's the thing, though. It's moving from a higher density medium, the higher density water, saline solution, to a lower density medium. If you keep adding increase the density of the water enough, the egg will just float on the top. But you take that same egg and you go up to a 3,000-foot cliff and you drop it off. Now it's falling from a lower density medium at altitude to a higher density medium as it dashes to bits on the rocks below. So what you have is a situation where, okay, in the saline solution, it goes from high density to low. Throw it off a cliff, it goes from low to high. If it were solely due to relative density and nothing else, it would go in one direction, either high to low, low to high. You can't have both. That right there is the big indication that there's something else that Anthony Riley's not taking into account. And gee, I wonder what that is.
Now, I saw that video. Well, we all saw that video that he did. And he tried to invoke Newton's third law as for relative density being a force because he caused a change in the density of the water. So as engineers, what is wrong with that statement?
Well, there's stuff wrong and really kind of stuff right. Buoyancy is considered a pseudo force. It's not really a force. It's gravity that provides the force. It's gravity that wants the fluid, in this case the water, to maintain its structure, to maintain a water level at the top of that particular column. So it isn't so much that it's wrong; it's that they're not really looking at it with a critical eye and looking at it completely. Blue?
Yeah, if you go by that theory that things should be moving from to the lower density, as you were pointing out. I mean, everything should fall up, not down.
Correct.
Things are going in the wrong direction. Yet all of a sudden you put the egg in the water and it goes the opposite direction. Yeah, something is wrong. What's wrong is there is no force associated with mass by itself, unless you've got an acceleration to go with it. You can't have a force simply from mass alone. That's where Anthony goes wrong.
Exactly.
And Amy is alerting me to more comments, so we'll let her step in here for a moment and see what's going on with the live chat.
Sure. I've got some great comments from Demonic Davros tonight. He says, relative density is just the ratio of density compared to the density of water. Has nothing to do with motion. And gravity pushes on the material around the object. And relative density is the difference between density of an object compared to density of water. I also have some great comments from Ugly German Truths. He said, water is a liquid, so more density equals more molecules per unit volume, which reduces their ability to be squeezed out of the way as other water molecules are already where they need to go. Buoyancy is the point where density of packing equals the force a heavy object can exert on the water to push any molecules out of the way. And the result is the water will give resistance and no longer evade to the sides or up of the disturbing object.
Yeah, those are good good synopsis of what's going on.
Yeah. Now we have been focusing a lot on water. What about like helium balloons, butterfly smoke? They like to harp on those things too. Well, if gravity was real, then a butterfly couldn't take off or a helium balloon couldn't float. To me, and correct me if I'm wrong, gentlemen, but that has a lot to do with other factors. And it seems to me that the conspiracy theories type people, they want to just look at one variable. They don't want to look at things like aerodynamics or the density of the helium versus the density of the atmosphere and that kind of stuff. I don't want to get so focused on water that we forget about that side of the argument as well.
No, it's you got a good point. The helium balloon is, of course, the same buoyancy that we're talking about with the water. It's fairly easy to demonstrate that with a small vacuum chamber. You can find those videos online. Place a helium-filled balloon in a vacuum chamber. If you, provided you don't cause the balloon to explode. Once you take the air away out of that chamber, that balloon will no longer float. That helium balloon will sink every time. So it's exactly the same. It's the same principle, Archimedes' principle, that applies to water applies to the helium balloon. But now move on, going on to the butterflies and things like that. Yeah, the butterfly is providing its own propulsion. That thing is flapping its wings and using the resistance of the air it's in to fly. That's how it can do that. There's also a interesting video I saw somebody did, I can't remember who now, where they put some house flies in a vacuum chamber and took the air away. The house flies can't fly when you take the air away. So, it's a bit of an indication of what's going on. Airplanes wouldn't work if it were not for the fact that we have an atmosphere. Once you get to a high enough altitude, the plane can't go any further than that because there's not enough air there to provide the lift to support the weight of the thing. I think I'm rambling a bit.
No, you're not at all. It's all very interesting. A lot of people, even non-conspiracy theorists, do seem to have a hard time wrapping their head around multiple forces acting in conjunction. And
they seem to lose sight of the fact that the apparent force of gravity is completely dependent on the mass of the object involved.
And the other thing, you can think of the helium balloon in the atmosphere it's exactly the same as the egg in the water column. It works exactly the same. You get the exact same results for the same reasons.
So one thing that I know what to expect because I've seen it so many times, but at the same time, I can't really describe it as well as somebody like you guys that are more educated in the math and the physics and engineering, is the helium balloon inside of a car. Mm-hmm. When you accelerate, it wants to move forward, but the conspiracy theorist says, well, it should be moving backward. It seems to move opposite what you would think. And I can kind of sort of visualize in my head why that is, but I can't really explain it because I don't have all the math and the engineering.
I don't think you really need any math. If you take that car, take the video of that car, and the balloon in the car, and you accelerate, and the balloon goes forward. It's the same thing as Riley's egg. The air in the cab of the car. Obviously, it has its own inertia. It is mass. It does have its own mass, so it's got inertia, and it's going to resist movement until it catches up to the car itself. So the density of the air in the rear of the cabin will actually be so slightly higher than the density in the forward end of the cabin as you're accelerating. So that increase in density back there causes that helium balloon to go in the opposite direction. Just like if we dumped salt into the water column and increase the density of the water, and the egg wants to move up. It's the same thing. It doesn't seem like it should be, but the atmosphere is a fluid, just like water is a fluid. One's a liquid, one's a gas, but they're both fluids. They flow and will always take the shape of their container. That's the definition of a fluid.
Okay. I hadn't even considered the idea that, when I accelerate in my car, that, it creates a pressure differential between the front of the car and the back of the car. Just so slight that I don't even feel it.
Oh, just like our atmosphere. It's exactly the same thing that happens in our atmosphere. That's why the pressure, you get the pressure decrease as you go up in altitude, right? Everybody knows that. Pressure decreases as you go up. Same thing happens in the car. Exactly the same thing, except here in our atmosphere, the acceleration is the acceleration of gravity. In the car, it's the acceleration of the car that's causing it. But it's precisely the same phenomenon.
Yeah, you can feel it. When you hit that gas, you can feel yourself being pushed at the back into your seat. It's the same thing for the air in a car.
And Jeff, I haven't heard your voice for a few minutes here.
I've been sitting. No, actually, these guys have really explained it well, I think. However, I read something a little earlier today about how gravity can also affect light. Could you expand on that a little bit?
Oh, sure.
Yeah,
go for it, Mike.
Well, like gravitational lensing, things like that. I found that quite fascinating.
That was actually one of the first proofs, one of the first evidences of general relativity. One of the things and actually Newtonian gravitation also predicts bending of light, but just not nearly as much as Einstein and general relativity did. Everything is subject to gravitational fields, even light itself. That's why a black hole is black, because gravity is so large that the light from within that can't escape. So what they did is during an eclipse, a total eclipse in 1919, and anybody who's ever seen a total eclipse, when you get to the point of totality, you can actually see the stars in the sky. Well, what they did was they picked a constellation that would be about off to one side of where the sun and the moon are going to be during the eclipse. And one of the stars would be actually hidden behind the sun. But because of the predictions of general relativity, that light should bend around the gravity well, around the curved space around the sun. And they should see the star, and it should be in a slightly different position it would normally be in. And what they did was they used Einstein's field equations, calculated what they should see, where that star should be if Einstein was right. And lo and behold, when they ran the experiment, went to watch the total eclipse, that star was almost exactly where Einstein predicted it to be. And if you read general relativity, you'll find that it talks about everything is energy, whether it's light, whether it's mass. It's all some form of energy, and now all of that is what curves all that space-time around all objects. Even small objects, even like us, we have mass, so we technically curve space-time just sitting on our chairs watching TV. It's one of the coolest and one of the first proofs of general relativity, and it's something that's been done over and over again, since 1919. But that was the more famous one because it showed he had it right.
Oh,
So-
on any given night, astronomers with nice, big, expensive telescopes can stare out into the cosmos and see gravitational lensing, the bending of the light from a distant galaxy around a nearer galaxy. That's observed all the time.
They have to take all that into account when they're mapping the galaxies too.
Yeah, and as Mike says, everything in the universe bends space-time a little bit. Even us. Unfortunately, some of us bend it more than others do. But...
Yeah. I'm going to get bruised in the ribs because Amy keeps poking me for comments in the live chat. So let's go ahead and see what she's got going on over there.
Sorry about that. Ugly German Truths ask, but isn't ironically gravity also a pseudo force, at least when you leave classical mechanics where it's treated like one and go into what causes gravity? Then we have the helium balloon moves forward because it is more susceptible to acceleration. That's from Demonic Davros. And then Ugly German Truth says, can you ask them if the effects are the same when you use similar objects in a water tank in the back of your car? And does it affect light, or does it warp the space the light needs to travel through? And then Demonic Davros said, depends on the mass of the object will determine how much light bends. That would be classic gravity lensing or just lensing. That was a lot to digest. I'm sorry about that.
The first one, the water tank one, I suppose, but water is an incompressible fluid, so you're not really going to get a density gradient in the horizontal direction due to that motion, unless, of course, there is already a density gradient, like it just needs to be stirred up and water from below sloshes up the back. I guess you could. But it isn't as easy to quantify or observe as it would be in a situation where you have a gas versus a liquid. And the amount of gravitational lensing, the amount of curvature is proportional to the mass. The bigger the object, that's why we needed to use the sun, because there wasn't an object in our solar system with enough mass in order to be able to test that part of general relativity. That's why it was a very opportune situation to have the total eclipse.
We've been discussing a little bit about Newtonian gravitational equations as well as Einsteinian equations. I've heard quite a bit from the conspiracy theorist crowd that they seem to think that the one replaces the other. They keep using that stupid phrase of snapping the wand. I think it should be noted that nothing is getting replaced. It's really just getting refined, right?
Yeah, and it depends too. Like because of our framework, I use gravity in my equation, in my calculations on a daily basis, either directly or as vector components. I do stress analysis on things on seagoing vessels. So, sometimes it has to break it down to a component because the boat's rocking and rolling at sea. And no, I don't use Einstein's field equations for that. This is classical Newtonian gravity that we use to design things like ships at sea and bridges. And it has nothing, while Einstein is the cause of what causes things to accelerate, the effect is still quantifiable and verifiable and repeatable using Newtonian mechanics. It's ridiculous to think that one supplants others. Now, if we lived on the moon in a moon colony, yeah, those equations would change slightly. The variables would be the same. We'd still have a little g. We'd still have an m for mass, but the little g would have a different value. That's the only difference. But as long as you don't have relativistic speeds, speeds approaching the speed of light, or incredibly massive objects like a Jupiter-sized planet or a sun, the standard Newtonian equations hold, they work, and they're very, very accurate.
Well, I think Einstein himself said it best. He wrote a letter to the London Times that was published on November the 28th of 1919. And if I may, let me read just the next to the last paragraph. It's very short, only 2 sentences. Einstein, in his own words, said, "Let no one suppose, however, that the mighty work of Newton can really be superseded by this or any other theory." He's talking about relativity. He goes on to say, "His great and lucid ideas will retain their unique significance for all time as the foundation of our whole modern conceptual structure in the sphere of natural philosophy." Now, Einstein didn't think he superseded Newton. I don't know why Anthony Riley thinks he did.
Well, because it fits a narrative, obviously. But yeah, I think part of the problem with people that get into the conspiracy theories like this, they seem to think that because we don't know exactly what something is, but yet we know what it does, therefore fake. There was a time we didn't really know what lightning was either, but we knew what it did, right? And eventually science caught up, and asked enough questions and ran enough experiments. We figured out that lightning and electricity, yeah, that's exactly what it is. And here's how we can use it. But so I guess it starts to get into the realm of theoretical physics when you start asking the question, what is gravity? What is it about mass that causes a gravitational field? Or not?
No. It would be wonderful to have every answer to every question, but you don't necessarily need every answer in order to use something. Let me give you an example. Go ask your doctor how many medications he prescribes every day that no one understands why they do what they do, but they know what they do, so they use them. And this discussion is a bit similar to that. We don't have to know the precise every detail of the precise cause of gravity in order to be able to use it and understand what to do with it. I think that's where the train jumps off the track way too often.
Oh, most definitely. I think eventually scientists sometime in the future will be able to answer these questions, but just not today, and definitely not in my lifetime. But that's kind of irrelevant. When it's still usable, workable, repeatable, observable. I just don't get why conspiracy theorists just say, nope, it's got to be fake because I don't get it.
Yeah. It also goes back to that whole cherry picking. I've been through all of general relativity a couple times recently, looking for something in there that Einstein actually says it's not a force. So I don't know where that quote comes from. I may be missing something. Einstein says gravity is not a force. I mean, it's implied in the paper that it's not a force as we classically think about it. But in like, let's say section 14 of general relativity, Einstein says it'll be shown that the equations arising from a purely mathematical way are the condition of general relativity, give us the Newtonian law of attraction as the first approximation, and the second to the explanation of the perihelion motion of Mercury. My view is that these are convincing proofs of the physical correctness of my theory. He's saying right there that because my field equations match Newtonian gravitation, my field equations must be correct. They are part and parcel to the same thing, and they're different ways of expressing the same thing. Whether we want to call it a force in classical Newtonian mechanics or use the Einsteinian field equations so that you can measure gravitation in the absence of matter, doesn't matter. It is irrelevant which you choose to do in a given frame of reference. But all over the place, he uses his field equations matching some aspect or completely matching Newton as a direct proof of his theories.
And I think that's exactly where the conspiracy theorists' arguments fall flat, is that these equations and the idea of gravity is predictive, and we can run the math, see what it's supposed to do, run the experiment, watch what it does, and find that the gravity equations accurately predicted it, and they have nothing predictive to replace it. To me, that's absolutely ridiculous that you're going to try to naysay something without offering an alternative.
And I love how they naysay something with that something, like the Cavendish paper. Riley loves to cherry pick stupid little facts out of that, but he completely ignores the last page where he says that the experiment was a complete success and allowed him to calculate the density of the Earth to great accuracy. We'll just ignore that part of it.
Yeah. And Amy says that she's got more comments from the live chat. We'll go ahead and let her jump in here at this point.
Yes, please. I have one from Peter Harrington. He says, seeing stars on the other side of the sun is a good example of bending light. And then Linda Bertelson says, Anthony Riley is an idiot who thinks he can prove his theory while twisting things around to fit his narrative. And then Ding. That's okay. Mm-hmm. And then Ugly German Truth says snapping the wand is a reference to something in the same article where it explained that Newton did not know what caused gravity and thus had to believe it was an almost magical instantaneous force. Thus wand like in magic. Einstein removed the mystery around the effect and showed it was happening with measurable time passing, not instantaneous. So by turning the old pointless assumption on its head, he broke the wand that had been used as a crutch before they knew where it comes from. And Ugly German Truth also said, I like to use the optical image that relativity is what was hidden as the eye in gravity. Einstein put more into the theory, but it's still embedded into the old model, just in a different direction.
And you missed one very important comment there, Amy.
Okay.
Dick Dawson just told me in the background where you could see it. He says, this could be the Amy show. There's so many good comments. You guys get out of her way already. I don't know about the rest of you guys, but yeah, I'd rather hear Amy's voice than mine right now.
For sure.
Thank you.
I also remember reading somewhere that Einstein suggested that maybe gravity isn't best described as a force. There's big differences to saying that it isn't a force.
Well, that's I think that's a very good point. I mean, Einstein clearly didn't believe that he was replacing Newton in any sense of the word. No. Newton, on the other hand, remained concerned throughout his entire life that he was unable to come up with an explanation for why gravity did what it did. Now, he knew what it did, and he was perfectly happy that his equations were correct in terms of being able to calculate those forces, or the acceleration is the way I'd rather think about it. But that's the reason why Newton said, and he said, I can only paraphrase this. I don't have the exact quote in front of me, but it was in a letter, an exchange he was having with another gentleman, and he basically said, I don't want you to ascribe innate gravity to me. I don't want to be associated with that, because Newton's concern was he couldn't understand what part of matter should cause things to do what they did. It just didn't make sense to him. So he didn't want it said that that's just the way things are, and because I say so. Later on, Einstein, thankfully, was able to sort all this out, and in a very elegant explanation of the real world that basically says matter tells space-time how to bend, and space-time tells matter how to move. It's that simple.
It is. Yeah. I love that way to phrase it too. In the very, very end of book 3 of the Mathematical Principles of Natural Philosophy, Newton goes on to say that he actually calls gravity the subtle spirit, and that we have furnished with sufficiency experiments required to accurate determination and demonstration the laws by which this spirit operates. But he spends a few paragraphs explaining we don't know what the heck the spirit is. We don't know how it works or why it works. Well, we do know how it works, and we can define how it works, or we can predict how it works. We just don't know where it comes from. And he knew that, and he said that, and he explained it very clearly in his book.
Yeah.
Yeah, so the cherry picking is just, that's getting out of control with the conspiracy theorists. You can't just take one little phrase and ignore what came before and what came after and say, oh, my point's proven. Well, no, because you didn't keep reading, dummy.
Yeah. Well, and the Cavendish, students every semester in universities all around the globe successfully complete that as part of their physics degree. It's not some magic stuff that is so difficult to do that nobody can ever complete it successfully. Yet if you listen to globe denying conspiracy theorists, there's just so many problems with it you can't possibly complete it. Heck, I did it in high school in the aeronautics club in like 1979. We had an actual apparatus that our student advisor had gotten from one of the local colleges. It was one of those ones like you could buy on Amazon right now, only a little bit bigger. So it was easy to set up and run, and we were a bunch of high school kids. We were able to do it in 2 days. But it's not impossible. He just wants you to think it's impossible, so he just cherry picks those things out of Cavendish's paper and ignores the last page where he talks about how successful it was. Papers like that, the thing you got to realize is papers like that, like general relativity and Cavendish's paper on his experiment, they have to explain why it is they did what they did and what the results were, because it's going to be peer reviewed and people need to look at it and know. And when they have questions, it's either already answered or they can get it answered. So they put all that in there to show, hey, this is the problems I ran into. This is how I fixed them, and then here's the results.
Yeah, people like to call the Michelson-Morley the most famous failed experiment in history. I think that's the wrong way to look at it. I think because even a null result in a scientific experiment still tells you something. So
it does. It's the whole point of science, to learn something out of what you're doing.
Otherwise, what's the point of doing it?
Yeah, and the null result's not the same thing as a failure. A failure to me is when you don't take in all the variables. You just didn't think of something and your results got skewed because of that.
Well, no, failure is floating a frigging egg in salt water and ignoring that gravity caused it.
Yeah.
That's a failure.
Yeah, big time.
Yeah.
if you want a failed experiment, do it that way and ignore one primary component, one primary constituent of the experiment. Just completely ignore it.
Yeah, forget.
I did when I did a debunk on Anthony's silly egg thing. The analogy I used, and I've heard others use it since, so it must have been a good one, was I could do the same thing Anthony did and say, okay, I can prove that I can make my car move simply by mashing the accelerator pedal. And that's the only thing that causes it. All I have to do is mash that pedal and the car will move. Now that ignores, of course, the engine, transmission, drivetrain, the entire damn, part of the vehicle.
Tire on the road.
But using Anthony's logic, I could associate simple movement of my right foot on the accelerator pedal with the movement of the car, and that's the only thing that happened.
It's amazing how a guy claims to be such a proponent of the scientific method gets it so wrong.
It's toddler mentality. I scream, I get cookie.
Well, that's exactly it.
I don't think he needed a lab coat. He needed a straitjacket.
Exactly right.
Well, we seem to have a little bit of a lull in the conversation, so why don't we take a look at Amy and taking a look at the live chat and see if they've got something going on. Amy,
absolutely. Let's see. Can you hear me?
Yeah, I got you.
Oh, yeah, we can hear you.
Okay, good. Okay, Ugly German Truth says Riley did not measure anything. He did not try a control experiment. He did not try anything to exclude other causes, like filming the glass in free fall. He did a carnival trick, not science. And I agree with that. Mm-hmm. And let me see. I have some other ones saved over here. Yeah, I think that was it. Yeah, that was the last one. I'm sorry about that. But yeah, mostly what Ugly German Truth had to say, which was a good one. So.
And a panic ladder likes cookies. Okay.
There's a couple of bigger, couple more holes that I think we should cover quickly in the whole relative density thing as being a force. There are definite clear, like we just talked about earlier about the egg and the difference in direction that the egg travels depending on whether you throw it off a cliff or float it in saline. Well, there's other ones too, and one of which was discussed by Bob. There's a 15-degree drift nodal and Jeranism, and that was a gravimeter. And the basic gravimeter works on there's a mass contained in a vacuum chamber, and the device measures the relative position of that mass within that chamber. And you could take that gravimeter, set it up anywhere on the globe you want, and it'll measure the acceleration of gravity in that location. And it's not the same. It's different. And if it were solely due to relative density, well, then that sealed vacuum chamber, the relative density between it, the medium in there, and that mass doesn't change. So it's clear that relative density has zero effect on the value being measured by that meter. And I could take 5 objects up to the top of a cliff that are identical. They have the same shape, they have the same volume, they're made of different materials, so they have different densities. And I could drop them one by one off that cliff, and they're going to exhibit the exact same acceleration, regardless of what the relative density between the atmosphere and that object is. Not only that, but as it's fallen from that 3,000-foot cliff, the relative density changes, and yet the acceleration remains constant. And then I could drop 2 of those objects off, and you want to know something? They're going to hit the bottom at the exact same time. And all of this is a clear demonstration that relative density has absolutely zero effect on how and why things fall or how and why things become buoyant. And if you take all of this, and if you're honest, then you have to say, okay, there's something else going on here that we're not accounting for, and relative density isn't the end all to be all. Just wanted to throw that out there.
Yeah. Sense.
And, go ahead, Jeff.
Oh, nothing. I was just agreeing with Mike. It makes perfect sense. I mean, there's so many things about gravity in general that they just ignore because it doesn't fit what they're trying to sell.
Yeah. They so want gravity to go away. And that's the other thing I don't understand. All right, if you got a flat Earth under some sort of a glass dome, there's all kinds of magic going on there. Why does that preclude gravity existing? It doesn't make any sense to me. Whether gravity exists or not, they still, claim they live on a flat Earth. One does not necessarily have anything to do with the other. You got magic happening to make it flat. You can have magic that makes gravity still work.
Well, I guess they're under the impression that if gravity's real, then a flat Earth can't exist because gravity, given enough mass, will try to tend to pull things into a sphere. It's
Right.
the only thing I can think of.
That is where it's all started from.
Yeah, I think that's a big part of it, and I think they are terrified of gravity because that explains why we do have an atmosphere on the Earth and why it is possible to have that pressure gradient that we see and measure, and why space is perfectly plausible.
Yeah.
Yeah.
And I watched Bob Nobodell on his channel play with a gravimeter, and he was actually kind of arguing gravity, but I think he was starting to go into the direction of the electric universe. And I think there's a total misunderstanding between weak forces and strong forces.
Mm-hmm.
We know that gravity is a weak force, where electromagnetism is a strong force. Could you guys address that a little bit as to why this idea of an electric universe instead of gravity would not work and doesn't happen in reality?
Well,
I'm sorry, I threw you a real curveball.
yeah, I'm thinking I'm thinking about the best way to answer that one. Magnetics makes no sense.
Mm-hmm.
I mean, we're not magnetic, so it's not the magnetic part of it. Is it the electrostatic part of it? Electrostatic forces are not that strong either. In fact, I think you could quickly prove to yourself that you would play hell trying to get enough electrostatic force to cause the effect that we see with gravity, even though gravity is the weakest of the four forces. One thing I like to say about that too, which gives them a little bit of heartburn. They talk about gravity. They'll question gravity being a weak force, and I say, yeah, it is a weak force. Let me tell you how weak it is. If you get enough mass together, gravity is so weak it won't even let light escape. Think about that. Now, tell me how weak gravity really is.
Yeah.
That for the guys that question whether water can stick to a ball or not. Yeah, it can. All you got to have is a big enough ball.
And gravity also acts over it's weak, but it acts over very long distances. Yeah, a magnet or some sort of electromagnetic field does not. It loses all of its, capabilities to provide force or direction or whatever it's doing at the given point in time. There's no way it could act over the distances that gravity does.
Yeah, I mean that's in fact how we discovered the position of Neptune by its gravitational effects on Uranus. I mean that's a huge distance. Come on, electrostatic forces I don't think could come even close to being able to do that.
No.
Yeah, and I love it when the conspiracy theorists say, "Show me water sticking to the outside of a ball," completely discounting the gravitational field that they're standing Yeah.
Yeah.
I just want to scream at him, say, "You're standing on it, dummy."
Yeah.
Yeah.
And a lot of so-called experiments or demonstrations. I mean, Daniel Pratt's got quite a few of them. His little bendy tubes on his grill, and drones flying over carousels. It shows their complete lack of understanding how gravity's supposed to work. Because in any world where gravity does exist, or even in a world where gravity doesn't exist, you're going to get the exact same results on all of those demonstrations that they propose to be done. You pour my favorite one is right to hand's favorite, where you pour water over objects and the water doesn't stick to it. Well, okay, so if gravity doesn't exist, then pouring water over objects, water's not going to stick to them. But if gravity does exist, you know what's going to happen? You're going to pour water all over the objects, and the water's going to fall to that huge, massive object called the planet Earth, and not stick to whatever object you're pouring the water off. You're going to get the same results. So it proves absolutely nothing.
Nothing at all.
Yeah, it's just silliness.
Yeah, which is why on
Daniel Pratt bending that water tube over his barbecue. Well, of course it's going to flow to the ends. I mean, you're standing on 5.5 trillion megatons of planet Earth. I mean, come on.
Yeah, that would have an effect, all right.
Oh yeah.
I mean, I have to say this, one of the most ingenious and simple to do experiments was Big Blue when you did the tube with the butane without a sealed end.
Oh, I love those videos.
That would not work without gravity.
No, it couldn't. It absolutely couldn't. And they're still raising hell on me about that, calling that open-ended pipe a container. Well, okay, call it whatever you want to call it, fellas.
Oh yeah. How many times did they move the goalposts on that one?
Oh my God. But the fact of the matter is, in thermodynamics, we don't talk about containers. We talk about systems. We talk about closed systems, open systems, or isolated systems. And isolated really doesn't exist. It's a theoretical thing. But that pipe with an open top on it is what we would call an open system. It will allow the free exchange of energy and matter. What's stopping that? What's
I'm
stopping
sorry
that
to interrupt
butane?
you guys. I'm sorry to interrupt you, Blue, but I've got a countdown in the background before Amy's head explodes. Apparently, she's got some really good comments that she wants to alert us to. And we do not want Amy Brain on the ceiling.
No, because my son would have to clean that up. That wouldn't go well.
Ew.
Yeah. I have some comments from Ugly German Truth. He says, obviously sinking even a bit into another object and displacing parts of that needs energy of force behind it. Where does that come from if there is only density? And then Truth is Not a Hoax says, which is Jut Monkey tonight, what about when an egg goes bad? Has it somehow defied gravity because eggs float when they go bad? And then...
Ew.
Is right. Ugly German Truth again says, well, a god could make an earth that did not curl up into a ball, but on a flat disk endless plane you basically do not get any point that has a perpendicular gravity vector, because almost always most of the mass acting on you is to one side of you, so everything would be slanted, and if it's a disk towards the rim you would almost crawl on your belly. If it were magnetism you could make free energy with any loop of copper wire, just swing it around and a flow of electrons would be induced from the EM field.
That would be true.
Yeah, it would be. That would be nice. That's swinging that thing around and power my house.
Oh, yes. Be a lot cheaper than the electric company.
Yeah, but I'm still waiting on Flat Earth to tell me why that butane wasn't immediately ejected into the atmosphere. I mean, I measured the pressure, and it had a noticeable pressure and a gradient to boot. Imagine that.
The pressure greater than the atmospheric pressure around it, so and still contained.
Yeah, but it's an open system.
Yep.
There was nothing stopping that butane from going out the top of that pipe. Not a thing.
Nothing at all.
How can that happen? You can measure the gravitational acceleration with any accelerometer. I used the accelerometers in my telephone, and that was an interesting experiment. I don't know if you guys saw that one.
Oh, I saw that. It was a
Yep.
good video.
Yeah, I saw that.
But yeah, you can show the without using the gravimeter function on the phone, just the accelerometer. You can show it that way, and it's very clear what's going on.
Yeah. Not much question.
Actually, you just gave me an idea for a funny little spoof video on my regular channel. I was thinking of the church lady on SNL. Yeah, I was thinking, could it be gravity?
Yeah.
Isn't that special?
Well, let me send you a clip I have of Arwen,
Oh, dear God.
because it'll fit right in.
Oh,
That guy's
goodness.
a card.
How long have we been at this anyway?
I don't know.
About 20 minutes or so.
An hour and 10. Yeah.
Yeah, okay. I think we still got more left in this. We still got 24 people watching. You know.
One of the other, and we touched on this a little bit earlier, but one of the other problems with relative density is directionality, is that vector, and the response that this one guy had to that, it just goes to show the lack of understanding and a certain level of dishonesty in the reply. Riley wanted to explain the vector of things falling through relative density. So what he did was he read the definition of a vector. Okay, that's fine. And then it says relative density provides a vector. It's like, well, there's a serious letdown. Are you going to tell us how that happens? Because that's what the question was to begin with. And it's just another level. I don't even know what a logical fallacy you would call this, but it's akin to saying that the sky is blue because that's what color it is. And that's just another in a long line of unanswerable questions that indicate and show that there is more going on out there that relative density is not accounting for. That's really like my last little dig at that.
Yeah, it's the inside of the mind of a conspiracy theorist to find out why they come up with these ridiculous arguments is I'm not sure if I want to dig that deep into it. I'm
Some things you just don't want to know.
Friends and a flashlight and a guard dog, because that's a scary place to be.
Yeah.
It is. It is.
It shows the lengths he'll go to, and it's the sort of comment that would appease his followers, but it really doesn't answer the question. And I don't think any of them really care that it doesn't answer the question. For them, it was good enough. It's the level of dishonesty and fallacy is huge.
I don't think they really want to know the answers.
It's part of why they want math to go away, because they if things are quantifiable and repeatably verifiable, then what their ideas go out the window and ours are maintained. But if you make the math go away, you can say what you want and you don't have to prove it.
Well, we got a little bit of a lull in the conversation, and at this, we usually like to keep this really intellectual on this channel. But given the conversation up to this point, I think we ought to ask Dick Dawson to come in and have give his thoughts on this thus far. Dick, you there?
I am, and thanks for having me on. Now, let's look at a couple of things here really briefly. Number one, Flurfs obviously can't do the math because how do we have density without a force? You can't. And so gravity's in the equation. And as such, if you could do math, you would understand that you can't have buoyancy without gravity. I mean, isn't that just simple? Number two, before we get into the disingenuous little pieces of that these guys usually are, because quite honestly, most of it's snake oil salesmen, I do believe. If density is the factor we're looking at here instead of gravity, if I'm standing in an area that might be like, uniquely microclimated due to the fact that I'm near the edge of a cliff, and so I have a slightly different pressure on one side or the other if I'm like 90 degree to a corner, how come things don't fall sideways? Why don't things fall up? When it's less dense above me than below me. The argument makes no sense at all, even from my somewhat layman's approach to this. It's absolutely ridiculous. So there's one thing I can take away from this. Somebody like a Riley or somebody, you're a snake oil salesman, little POS, and I would love to take that snake oil bottle and stuff it up your rectum and see how far I can get it, because holy God, you're selling awful crap. And to the other ones that follow him and whatnot, like let's say 33 you see there, who's literally just a human puppet for Russian Vids' hand. When they start selling their crap on this line, they have no idea what they're talking about. They're so far from the mark. It's absolutely ridiculous. And I got to say, Mike and Blue, you guys are nailing this. It's absolutely phenomenal conversation. And the chat is flying. This is unbelievably good stuff.
Thanks, Dick. I appreciate that. And for anybody that doesn't know, that's what we call getting mushroom stamped.
Yep. Nice and hard.
So, what about you, Jeff? You get any thoughts on this so far?
Well, as Dick said, this has been a very enlightening conversation. I learned some stuff. I got to be honest. I have a very layman's level understanding of all this stuff, but it makes sense even when it's explained by guys like Mike and Big Blue. I don't have trouble following it because I want to learn it. And that's the difference between me and most conspiracy theorists. They don't want to learn it.
Yeah, I actually grabbed a couple of beers during the show just in case my brain started to fry during this conversation. But no, Mike and Blue definitely kept this completely understandable. And very, very reachable for anybody, even just at a high school level of education. I'm sure if they really wanted to, they could have really gone completely over our heads, but there's absolutely no need to.
No.
So well, Mike and Blue, we get anything else?
Yeah, that really wouldn't serve any purpose, would it? Logically. No. I mean, no. The idea is not to confuse people. The idea is to try to make it understandable.
Yeah.
And it really, at its basic level, is something that actually is easily discussed and easily brought up. And it's easily accessible to anybody who wants to understand it. And you can get crazy. Like, I've read through general relativity several times. I still don't understand half of what's in it, but there's no reason to get that crazy. That crazy is not what we live in our everyday lives. And to understand our everyday lives, you just need the little bits that we know we can calculate with a piece of paper and a pencil.
Yeah, I'll be damned at this point in my life if I'm going to go back and try to relearn how to handle tensor calculus again. I'm not going to do it. Sorry, don't need to. But for most of what we do on a day-to-day basis, and any of this stuff that we talk about, you need a little more than just basic arithmetic and a little bit of trigonometry. Nothing more than that.
Yep.
Yeah, and those words sound really scary to people: trigonometry, algebra, calculus. But like one of my college instructors told me at one time that the hardest math that you'll ever be faced with is the one you're currently trying to learn.
Mm.
You know, and that kind of put it into a good perspective for me when I was getting frustrated in school, and and kept me moving forward instead of slipping back, into whatever little rabbit hole some of these people have fallen down into. It's just a ridiculous place to be.
Yeah. Well, Mike's an engineer. Mike, in your day-to-day work, how often do you find it necessary to get into integral calculus or differential equations or any of that stuff?
I think in the past 20 years, I've only done it about 5 times.
Yeah,
it's not necessary to use for most things, unless you're trying to figure out something new or something that you can't explain with regular classical engineering equations. Yeah, there's no reason to do it.
That's right.
And if you can't explain to somebody how gravity works, that they can't just write some stuff down with a pencil on a piece of paper and use nothing more than the calculator on their phone, or that little calculator they give you away free at the bank, then you're getting way too complicated with it. It's not that hard.
Right. And Amy, is there any questions or comments going into the chat you want us to be alerted to?
Yes, actually, I have some really good ones too. Peter Harrington says they don't feel special. If the world is just flat, they were made to be here and special. And Linda Bertelson says that is the thing about flat Earth. They go out of their way to disprove the globe instead of just proving the Earth is flat. Should be easy because they are smarter than scientists. And then Truth is Not a Hoax says, Blue Marble Science, if the Earth is flat and water always finds its level, why hasn't the water pouring over Niagara Falls found its level? So that's a good one. And Ugly German Truth says it's probably the apophenia. They are so used to making wildest, jumpiest connections between anything, they cannot follow a clear step-by-step process that shows coherent, consistent connections. That's basically it.
Thanks, Amy. We appreciate that.
Thank you.
And,
yeah, we do have to look into Niagara Falls. Something's going on there.
Yeah, something weird.
Yeah.
We could call that a phenomena.
Electroflurspectivism.
There you go. Proof that water bends in all kinds of ways.
And I was just thinking, when I was in the 8th grade, I did a science fair project with my best friend, and his father was a police officer in town. And so we borrowed his radar gun, and what we did is the Galileo drop, right? So we did the calculations to show what the speed was at different points in the fall of the objects. And it turned out that the math was completely predictive. It was spot on. And that in itself proves gravity, because it was an acceleration. It didn't just drop at a constant speed. It picked up speed the longer it dropped.
Yep.
So if an 8th grader can do it, you'd think that a conspiracy theorist would be able to do it. But then that might require getting out of mom's basement and actually going and doing something.
That's true.
And then dealing with the answer. So it's not going to be what they want.
Yeah, that's the most difficult part with the conspiracy theorist, is dealing with the answers. Like AB Science said in one of his videos a while back, when does a good question become a bad question? Because we always hear that adage that there's no stupid questions when we're going through school. Well, he came to the conclusion, and I agree with him, that it becomes a bad question when you're just unwilling to accept the answer.
And you keep repeating the same question until you get the answer you think you want.
Or just keep moving that goalpost till you get the answer you want to.
Exactly.
Yeah. But I think we've pretty much beat this horse down to a bloody mess of jelly on the pavement, and it's not even quivering anymore. So unless our guests have anything more to add, we'll go ahead and run around the table with some final thoughts. Mike and Blue, do you have anything to add, or just want to go to final thoughts?
Final thoughts is good with me.
Yeah,
Okay.
I'm good with it.
Well, lay it on me, Mike.
Well, we've discussed gravity from every which way we could, and relative density. We've clearly shown that there's so many holes in it that they have to start considering there's something else going on, and we all know what that is. It's gravity. And we've also shown that Newton and Einstein agree with each other. Einstein actually used Newton. It's all there for everyone to see if they really want to do the right research. They want to read it and then go out there. They can learn it, and it's not that hard. Gravity works.
It does.
Yeah.
And Blue, any last thoughts?
Yeah, that mysterious big G gravitational constant appears both in Newton and in Einstein. Wonder why that is. Other than that, yeah, Mike summed it up very well, I thought. I believe it's time to stop the silliness, guys.
Yeah, completely agree. What about you, Jeff?
Well, I first of all just want to say thanks to both Mike and Big Blue. I learned a lot today. And I think this whole discussion all comes down to the simple fact that if you don't want to know the truth, then stop asking the questions. They know what we're saying is correct. They know what we're saying is true. They just don't want to admit it. And until they do that, we're going to be dealing with these idiots.
Well said. And Amy, do you have any final thoughts on tonight's proceedings?
I do. It was an excellent show. Wonderful conversation. Thank you both for coming on. It's been great. Gravity does exist. I dropped a book on my foot today. Yes, it does exist. It's there. Well, you have to have, don't you have to have an opposing force as well? As, you know, if something's floating up, something's coming down. I mean, there has to be something that opposes it. Gravity is there. I just wish that they would see that, or just admit that they're being trolls and that the Earth is a globe. Once again, thank you everyone for coming, and this has been a wonderful show. Thank you.
Thanks, Amy. And Teddy Bogle, you've been in the back working really hard, keeping the show running smoothly. And so why don't you open your mic and give us your final thoughts?
Just an absolutely fascinating conversation there, man. The chat has been excellent with the contribution as well. Some really good stuff in there. I have to say, Amy's been shouting out lovely. Just fascinating listening to you chatting about this, man, and just getting your thoughts and opinions on it. It's been really eye-opening. I'm going to watch this again after I get up.
Oh, that's right. You haven't been to bed yet. Your son's probably coming up now, isn't it?
It's light outside.
Well, I appreciate you staying up and helping us with this stream. And Dick, why don't you go ahead and give us your final thoughts?
Well, the flat earth community is always telling us about how they're all about doing their own experiments, unlike us who just, take the word of others who have done the experiments, never mind falsified and verified and on and on. So I would like to encourage everybody watching this to do your own experiment to prove gravity. Now, this is very simple. Go out into the public, in your hometown where you live, find yourself somebody who is a flat earther. Take a walk with them somewhere. And when they're not looking, stick your foot out and trip the son of a bitch and watch him fall and look at him and say, gravity!
Yeah.
Fun.
Oh, God.
Great.
Leave it to Dick to go off on a rant. I love it. I don't have really anything else to add to anything anybody has said other than For the people watching at home, just remember, stupid is a choice, and pick up a book. And if somebody you know and somebody you love is stupid, take their video camera away from them, hand them a book. Taddy, go ahead and push the button, take us home.